till now, you know the different types of data you use, like different colors like green, orange, blue, pink. Okay, so these are not colors only. Okay, so these are different data types in the LabVIEW. Okay, so today's this particular session will be we will talk about different data types. Okay, not about the programming how to do, but how the LabVIEW uses different handles different types of data in LabVIEW programs. Okay, so there are basically two types of data structures in LabVIEW. Okay, so one is called primitive or primary, which is common to all languages, and another one is secondary, which are user defined. Means like we define how that data should appear or how should be that data. Because as per our demand, we define some kind of data types and we use it for different applications. Okay. So in primary data types, there are like four data types. For example, string, numeric, Boolean, and dynamic. So string is basically a text. Okay, the number of characters is connected together and it forms a text sentence or something like that. Okay. So numerics, there are different types of numbers. It can be handled under this category. And booleans are used only for logic calculations. Okay, it is called true or false. It holds the true and false values, but it will be used for logic of your programs. Means this can be used for defining the logics of your program. If you want to see that your program given this result, if it is true, then go to the another logic and it will be decided by this Boolean type of data and its related functions. Okay. So another one is the dynamic. Okay, so this dynamic data type is special for LabVIEW. Okay, so specially LabVIEW had designed and it is used only for different kinds of express VI which are defined by LabVIEW. Okay, so you can also define, but it is more complex. So we use it as it is, and we don't do further things with this kind of data type. And there is another category, secondary, which is user defined. These are the arrays. Okay, so array is particular group of data. Okay, so group of data of same type. Okay, so under this array data, you can have like string type of data, or you can have numeric type, or you can have Boolean types, or something like that. So you can have a list of data collected together, but of the same type. Okay, not like one data is from string and one data from numeric. Okay, so the array is a collection of data having the same type. Okay, for example, you go for this or this or this or this. Okay, and the another one is cluster. The cluster is also a grouping of data, but it can handle different types of data together. Means this clustered kind of data you can use to store string or numeric, Boolean, or all together. So that's why it is different from this. Okay, so both are group of data, but array uses the same type of data while the cluster uses different type of data. Okay. Are you getting my point? Means what I'm trying to say. Different data types.
Yeah.
Yeah. So I can look at Kong and we will know now. So I will ask you only two. Okay. And if anybody else has a question, they can talk in between also. Don't wait for my presentation to finish. You can stop me anytime and you can ask me. Okay. So different data types means these are the different data types. Okay. So array can hold single data type but as a list of it. Okay, cluster can hold different data together. It can make a list of all the data as per your design. Okay, and then there is another called enum data. Okay, so enum data is kind of some different data type which holds the pair of values. One is like string value. String means like some kind of text. Okay, so it has some text, and along with that, there is one another value. It is number. Okay, so you make a list. Okay, you make a list of text, and that text has number related to that particular sequence. So if you make like you have one box, it is called enum box, and you put some data into that. Like for example, January, February, March, April. you will see it as a text, okay? But when you code it in LabVIEW, you will get its output as a number. So this pairing is done by this particular type of data type. So I will explain all and each of these, okay? So it is just overview of what kind of data is available in LabVIEW. Okay? So this is primary data. First we get overview about primary data, okay? So there is a string, numeric, Boolean and dynamic data. So on block diagram, it looks like this. You remember, right? So if you want to input some text, the text will be appear as a pink in color on a block diagram. Okay? So it is just a sequence of characters, ASCII characters. So those are the characters which appear on your keyboard. Okay? So A, B, C, 1, 2, 3, 4, and something like that. But apart from these characters, there are more characters which you do not see on your keyboard, but computer knows about that. So those non-displayable characters. So strings can hold these two types of data: the displayable and non-displayable ASCII characters. Okay, so this is string. So if you have like sequence of data, like if you have like sequence of characters, okay, so that will be a string type of data because we have the characters which are displayable ASCII characters. Okay, so this is string. Why it is called string? Because it is a sequence, and you put A, B, C as a sequence. Okay, so it looks like a string of characters. That's why we call it string type of data. And string type of data, what will be under that data type? I will show it in next slide. Okay? So numeric data type. Okay, so you already know there are two types of data. You seen the different color. Like one is orange type of and one is blue type of data. Okay, so orange type of data is floating point data. Okay, so which includes like decimal points. For example, 1.2, 1.3, 1.5. So those type of data is comes under floating point numbers. Okay. And the another ones are integers, like it can be -1, -2, -3, or 0, or 1, 2, 3, 4, 5, something like whole numbers. So those are the integers. Okay. So under this type of data type, there are two types of uh, this, overall categories. Okay. One is floating point numbers, and another is integer types of numbers. Okay. And there is a third one is a Boolean data type. As I mentioned, it is a true or false, or it can be in machine language. It will be like 0 or 1. So 1 corresponds to true and 0 corresponds to false. Okay. So if we talk about in machine understanding, it will be either 0 or 1. But for us, as it is graphical programming, we say it true or false. Okay. So this is Boolean type of data. It has only two values, either 1 or 0, or true or false. Nothing else. Okay? Only two values. And see, fourth one is the dynamic data type, which is special to LabVIEW, and it is not available in other languages. So this is only used for like Express VIs. Okay. So this Express VIs, we used in first example, like when we generate signal, sine waves and something like that. The VI with the blue background, it is called Express VIs. Okay, so they always gives out data of dynamic data type. Okay, they have this kind of color scheme for that. So when you want to handle some data from Express VI, which are made by LabVIEW, we always use this kind of data connections. So now I will go for all these four in some little bit details. Okay. So this is the data type, string data type, and what I was mentioning is like ASCII characters. Okay. So this table gives you all the ASCII characters available in our computer language. Okay. So you can see there are like A, B, C to Z, and some this another symbols and numbers. Okay. So all these are like displayable characters, right? But you see this one, for example, this tab. Okay. So tab is not displayable characters. We know it is tab, and its code is like 009, but we cannot see when we print it. That's why it is called non-displayable character. Okay? So this string data type, when use all these characters together, okay, different sequence of these characters, and this can be held by this string data type. Okay, so as string data type has no limit on how long will be the sequence, so there is no knowing before that this much data binary bytes are required to hold this type of data. Okay, so each character will have some byte data. Okay, so this is 1 byte, right? 032 is 1 byte. Okay, so if you use only one character, it will be having only 1 byte of data. Okay? But if you use like 4, then you will have 4 byte data. So as string is a sequence of different characters, its length is not fixed. So as you go on increasing the numbers of characters in that text, its size will increase. Okay? It is how it looks on a front panel. Okay? So this is string control and this is string indicator. Okay, and it is on block diagram. It looks like this: string control, arrow on the right side, and string indicator, arrow on left side. So we know these characters, right? 0, 1, 2, 3, and ABC. So strings can hold any sequence of these characters, and also which are not available to read. That also can be held by this control. So this is very useful when we try to do these things. Like for example, when if you want to make simple text on your control panel or block diagram, you use this kind of data type. And its most advanced, more advanced application is to control the instrument, like sending some text command to a particular instrument, and then that command is executed on that instrument. So, but when we send commands to instrument, it is not like only text. Okay, so it will be having like line feed or tab character or beep character. So that's why these string constants or string data types are very useful during their handling. Okay, so and another one is like storing the data. Means whenever you try to store your numbers on your hard disk using LabVIEW or any other program, it usually try to convert that numbers into string data. Okay, so always numbers are converted to text and then it is saved as ASCII file on your hard disk. Okay, and there is a fourth one. It is user friendly, means like it you can use these string constants or characters to help the user to know what you are trying to ask. And then we go to next data type. Okay, so these are the different data types of numeric type of data. Okay, so as I mentioned, there is a broad category is a numeric data type is a floating point, which is like 1.2, 1.3. It's like using having some decimal point. Okay, and integers are like only numbers 1, 2, 3, 4. So this table explains you what type of different data. Means these half types of data are integer types of data, and above this are all floating point of data. But this data type can hold a different range of data. Okay, so I mentioned like if you use single the floating point numbers, it can use this kind of maximum point. So when you use these floating point numbers, you see how much memory it takes in your memory, how much bits it takes in your memory. Yes, even though all are the floating point numbers, it has a different type of bits used to store the data. Okay, so for example, we generally use this many bits to store the number. So when I use this double control, the LabVIEW allocates memory in your disk of 64 bits for that particular number. Okay? So if you have some applications which uses very large number, like for example you see here for 6.48 rise to 4966. Okay, this is power. So this long number it can store using this particular type of data type. Okay, so when you put that numeric data type on your log, you will only see two colors. Okay, so how to define, like I want to set this particular data to this particular length or broad. Okay, so how to do that? Okay, so I will show you this one. Okay, so when you have some numeric data control on your front panel, right click on that and click on representation. Okay, so when you do representation, this block appears. Okay, this is all corresponding to this one. So if you want to change your particular control, for example, I had double data type, and I want to change it to I32. Okay, so you just click on this, and this will become blue on your block diagram. Okay, so
Yeah.
whenever you put numeric data controls on your front panel, it will look like same only like this. Okay, so, but its data range will depend on its representation. Okay. So to choose how much long numbers you want to store, you select this among these. Okay. So if you choose, like for example, I choose 1 byte data, U8 data. Okay. So 8-bit data. Okay. And its range you see 0 to 255. Okay. So when I select this as a data representation of my number, and if I supply like 256 value to this, what will happen? LabVIEW, what it does, it goes back to start. It goes to the next number. So what is the next number of this? Is go back to 0. Okay. So difference among all these is only number of bits they use to store this data. So as I mentioned, if you put a lower range and supply the higher value, the LabVIEW goes back to origin and start again counting.
Program still runs even if we enter input that is out of the range.
Yeah, it runs. It will not show any errors. What happens if I supply larger or smaller than the range? The LabVIEW does its own programming for it. Okay, so as I mentioned, like if you connect the data type which is lower in range but higher output, so it does something its own. Okay, so usually functions like these functions, when you supply, like for example, I use I32 number and add with the double number. Okay, but it do not output I32, right? It output double value because double is larger, right? It output in larger format.
You
Yes.
mean the result is with higher bits or higher range? Yeah.
Higher bits means like higher range. Okay, so when
Ah.
you store the data for larger bits, it gives you larger range. Okay? So and when LabVIEW does that, it shows you on your block diagram like this. You see this red dot? It is
Yeah.
called quotient dot. So when this happens, LabVIEW takes some extra time to do that, right? Okay. So that's why we always avoid this kind of dots on our program. Okay? But sometimes it's not possible. So we use some data conversion functions available on our programming palette. Okay. So when we put some data conversion function here, LabVIEW do not need to do extra work. Like if you assign a wider to smaller, it's like double is wider range, right? But when you assign to smaller range, as I mentioned, it will go back to its original and then start counting. For example, this number is assigned to this number. Okay, so this number can hold more than 255, right?
Yeah.
Yes, but when
Yeah.
you
Yeah.
assign this number to this one, okay, which holds only 255, right? So if I assign this particular number to like 500, it will not store 500. Okay? What it does, it goes after 255, it counts to 0 again. So 256 will be 0. So what it does, like it goes to rollover, means if there is smaller range, so after its full range, it go back to 0 and start counting 1, 2, 3, 4, 5, 6 again. Okay. So if the assigning number and assigned number are the same, there will be no problem.
Another question.
Yes.
Uh, what does this mean when they are the same bit and the LabVIEW chooses unsigned?
So you see here, I showed you here. You see I32, right? I32 is here, right? Yes.
Yes.
This
Yes.
is, you see its range is minus to plus, is it? This
Mhm.
is signed integer, okay? But you go back to here, Q32, okay? So it is unsigned 32 and it has no sign,
Yeah.
okay? It is from 0 to this. So this is how it chooses. Like it don't choose minus 1, but it choose only positive number.
What about the I32 and SQL? They have the same bit.
Which one? This one?
The first one and I32. Yes.
Yes, this has a same number, but it is a different types of numbers. You know, these are whole numbers. Like there is no decimal points here, okay? But it has the decimal points here. Okay?
So it will
1.4.
so
Yes.
it will still change to the one that have decimal points.
Wider range. Yes, it will go to wider range. Yes.
You say the number of bits they use to store data.
Yes.
So the LabVIEW will choose how many bits to
No,
store
no.
data.
This is fixed. This is fixed data bits. Okay. So this chart
Uh,
gives you a range of data. It's whenever you choose a double, these 64 bits are reserved for that number. When you try to store double precision floating point number, machine stores it in 64 bits. Okay. Okay, so next data type is Boolean data type. Okay, so Boolean data type is it takes only value of true or false, and it can have this kind of controls or indicators. Okay, so this is control and this is indicator, and this is also a Boolean control. Okay, so how it is Boolean control? Because when we press the button, its value change from false to true. So when it is empty, it is false. When we click it and it becomes like this, it is true. So these are the controls and how it looks on our front panel. Okay. So this Boolean constant is either true or false. As I mentioned, it is a Boolean control, but it has two types. Two categories are there. Okay. So one is called a latch type, and another one is switch type of buttons. Okay. When
Yes.
you press it, it will run. Okay, and when you
Yeah.
leave it, it will stop. So this mechanism, it is called latching mechanism. So stop is its a default value. So one value is default, and when you press it, it will change for some time, and when you leave it, it will stop again. Okay, it will go back to default. And another one is switch. Okay, switch is like switch. Once we on it, it remains on, and then we off it, it will go back to off. When you use this kind of Boolean control, you have a property of, but how to assign this property to our buttons? Means you can make this button also switch, or you can make this button as also latch on your front panel. So you see, this is a button. Okay, right click on that and go to mechanical action, and you get these six types of mechanical action. Okay, the top row is all the switches, okay, and bottom row all are the latching actions. Okay, only certain difference is that switch when you pressed. Okay, when you just click and keep your mouse or leave your mouse, no problem, but just only click, the switch will happen, means it goes to true to false. Okay, as it is mentioned like this is this. Okay? And this is switch when released. Okay, so you keep it pressed, and when you release your mouse key, it will do the true or false. Okay, so it remains down, and when you release your key, it goes up. All these are the switches. Okay, you see this symbol, particular symbol. So these are the switch type. Okay, and this is the latch type. Okay, we either go for this switch or latch. Okay? Fourth one is the dynamic data, which is like as I mentioned in our first example, we use this kind of VI. So it always give out data in this blue, dark blue line. So this is dynamic data. Okay, it has many things inside that data type. Yes, it has some arrays, or it has some numbers, or it has a 2D data, or it has some graph data. Okay, so it is a mixture of data. Okay, so you can connect this data to numeric. You can connect this data to Boolean, or you can connect this data to graph indicator also. So it can have its own properties which can change according to your inputs or output. Okay, so that's why it is called dynamic data. So when you use this data, you can connect this to another same type of VI, like Express VI. So VIs which have the blue backgrounds are called Express VIs. Okay, if you want to use it directly, you can use it. That's why it is called Express VI. So this particular type dynamic data is used for communicate between this type of Express VI. Okay, so this data can be used to connect to numeric. It can be used to Boolean, or it can be used for waveform graph, and also it can be converted into some arrays. Okay, using this convert dynamic data to different form, or convert from dynamic data. Okay, so this should be here and this should be here. Okay. So when you put this on a block diagram, it opens this dialog, okay, where you choose what kind of data you want to convert it, or which you want to convert. Okay. So when you put this dialog opens, and you select what kind of data you want to output or input. Okay. So for example, here I want to open as a waveform. So I select 1D array of waveform. Then whatever the data will come, I can directly connect to the waveform indicator. Okay. So this way I don't have this kind of red dot, some quotient dot. Okay. So these are the different data types you can convert dynamic data from or to. Okay.
What is dynamic data?
So this is dynamic data, one type of data, mixture of data. Yes.
So if we put the convert from dynamic data
Yes.
from the numbers or Boolean, we don't have
the red point. Yeah. So yeah.
Okay. He mean the convert to and convert from should reverse each other. Yeah. What's the reason for us to create dynamic data?
This particular Express VI does data type, which is called cluster. So this is kind of cluster data. Okay, I will explain it in next few slides. So this is cluster type of data, which is defined by Express VI. This is dynamic data designed by LabVIEW for their particular VI, Express VI. Okay, and if we want to take data out of that Express VI for our normal indicators or controls, we can use these functions. And now we go to the second one, which is our secondary data, where users can define a data type. Okay, so as I mentioned, arrays are a group of data of the same type. Okay, so the arrays can be of data of strings, or can be numbers, or can be booleans. Okay, and it has so arrays are group of data of same data type. Okay, so you can see here. Okay, so cluster is like you make a group of data. For example, here, so you see on this particular block diagram, all these three numbers are inside this particular line. So this is the same kind of data which was used in dynamic data, right? So dynamic data is just like collections of data put together as a cluster, and that is passed from one VI to another VI. So this is Enum. It is a combination of data types. So these are the data types which we can define ourselves as per our requirement. Okay. So first we go for like data types, user data type as array. Okay. Array has same data types. It is a group of data of same kind. Okay. So this is array of double, and this is also array of double. But what is the difference here and here? One number here and two numbers here. Okay. So every array, when we define on front panel, it has two values associated with it. This is dimensions, okay, and another one is elements. So this is index. Okay, when you put control on your front panel, it looks like this. One has index box and another has elements blocks. Okay, so you can add another dimensions. Okay, this dimension or two dimension. This is 1D array. Okay, because it has only one column, and it has a 2D array. It has two columns. Okay, so you can increase more dimensions also. Okay, so how to create arrays on a block diagram or on a front panel? Right click on front panel, then go to data container, and then click array. Okay. So when you do this, it will be like empty. Okay. So it will be empty like this. Then you drag it here, and it looks like this. Okay. This is empty box. Okay. It is called array constant. That means it is not defined yet. Okay. And then it will look like this on front panel, and it will look like black on your block diagram. Define this particular array as kind of data. We drag it some numeric. Okay, you click it here and drag it and drop it inside. It becomes like this, and this black icon on the block diagram becomes orange, or whatever the data type you want to use, it becomes like this. Okay, and you can do it similarly for different types of data. So for example, here you see I put integer inside the array, it becomes array of integer. Okay. I put double inside the array, it becomes array of double. So similarly, array of boolean, array of string, array of file path. Okay. So what kind of array you want, you can drag it inside this empty block, and it will become array of that particular type. So this is how we do on front panel. Okay. Now I will show you how you can do it on your block diagram. Okay. So here on block diagram, you right click and you go to programming and you go to array and you click on array constant. Okay. So when you do array constant, it will show you like this. Okay. So when you put array constant, it will be blank. Okay. So it will be blank and the arrow will be the broken. Right. But when you drag one constant inside this block, it becomes this kind of array. This is array of constants. Okay, it will have nothing on a front panel. It will only appear on a block diagram. Okay? So you can have similarly, like you can have array of integer, array of boolean, or array of string value, or array of boolean data. So it is array of constants. Okay. So there are some different array functions. Okay, you can see on array functions, and there are different types of functions you can perform on array. Okay. So for example, array size. Okay, when you design array and connect this array line to this function, it will give you size of your array. Okay. For example, if you have array of 6 numbers, okay, then it will output as a 6 of this function. So if you don't know how many points are there in your array and you want to know it programmatically, then you just use this function and it will give you the size of your array. Okay. So next one is initialize the array. Okay. So when you design one array, but you don't want to put manually input all the points. Okay. So just you make a program to do that. So you just connect the elements and initialize the array. Okay. So you can create how many elements you want to create in the array, and you pass it to that function, and it will finally give out you the array of your desired numbers or elements. Okay. The next one is the build array. Means you have array already, and you want to add more points to that array. Okay. So you just connect that array to this function and add extra elements you want to add, and then this all together, the first array plus the added elements will be occur as appended array. And after that you have index array function. So this index array, what it does, it takes the array, connect to this function, and you give some, for example, you have the list of points in one array, and you want to know what is the point at 3 numbers of index. Okay, so you use this function, pass the array value to this, and enter some value here, and it will give what is the value at that particular element or at particular index. Okay, so it is to access the data from your array. Okay, so then we have what's called array subset. Okay, so what it does is like you supply your array to that function, and you connect some values like from where to where data want to split from that array and make a new array. Okay, or take some portion of this array out of that. Okay. So you have many other functions. I will not go in details. Functionality available for this arrays. Okay, it is called polymorphism. So it is said that this numeric palette on your LabVIEW is a polymorphic. Used means it can work on scalar values as well as on arrays. Okay, use all these functions for either array or some single values. For example, I showed you here the first point. You see, this value is array, right? And this is just a simple number. Okay, this is some simple number. So when I use this array function, addition function, I can supply single value also as well as array value. Okay, and it can do its additions to it. So this is called polymorphism, right? Means one input is array, but another input is just single value. So even there are two different types of values given to the addition function, it can do the addition of array function. Okay. So this kind of functionality is called polymorphism. Okay. So you can add array to single value, or you can add array to array. Okay. And now here you see there are like two arrays, array 4 and array 5. Okay. So even it is a 4 elements, it is 3 elements. Okay. You can see the addition happen. Okay. So when you use the different dimension of array, it always outputs the dimension having the smaller array. So the another type, data type, which I mentioned was like mixed types. It creates the group of data which are the of a mixed type. For example, I create one cluster here, which I give name as a student. Okay, student only don't have only name, right? It will have some number. It will have some properties like he was passed or no. So if I want to save one student as a one information, I make a cluster. Okay, cluster of data. So you can make this data for yourself. For example, here you see, before I had like three types of data like ID, number, name, and pass as Boolean, and strings, and number. So when I make one cluster, I can have all these 3 points in the same line or same as data. So this is recreate. That's why it is called user-defined data. Okay. So on front panel, like data container category. Okay. So click on cluster. So we drag it on the front panel. Okay. And it will be like empty cluster first, and it will show you broken arrow because this cluster is not defined. Okay. Like we create first some controls which you want to put it into control as a cluster. Okay. So what you do, you select all these. I selected all these and drag it inside the cluster, empty cluster. Block diagram, the black icon becomes the pink icon, okay, which is related to cluster, right? And from block diagram, what you do, you right click on front block diagram and click on cluster, okay, cluster class and variant, and select cluster constant. Okay, you put on your block diagram, it will be empty. Okay, it will be some reddish color empty icon, and it will show you broken arrow, means it is not defined. Okay, then you have some constants and just select that and drag it to your particular cluster constant, and it will become a cluster of a pink color. Okay? So when you define a cluster, there is a one more property assigned to that. Okay, it is called ordering in cluster. Means when you put it in front panel, okay, so there are three controls, right? 1, 2, and 3, but in one cluster. So when you start your program, you go from one point to another point to third point to enter the data, right? So this is called ordering in your. So to define, for example, when you design a cluster, you may put this first and this there, this one. Okay, so it records that sequence in its mind. Okay, but you want to change it. Means when you use a tab on this control, it will go like what is the sequence already inside that cluster. So to change for our wish, we go for like right click on this go to Reorder Controls in cluster, and start clicking on what kind of sequence you want. So I want to make this one in the 0, 1, and 2. When I click Reorder in cluster, this happens, right? So black box is a new order, what I want to define, and white box is already inside that cluster order. Okay, so I want to define here as 0, 1, and 2. Okay, so what I do, just I click on this one, this number will change to 0. Then I click here, this number will become 1, and then click here, it will become 2. So when I start my program and use the tab key to go from one control to another control, it will always follow this sequence, 1, 2, 3. So this is called ordering in cluster. So yes, so there are other functions, okay, with cluster. So the specific cluster have some function related to the cluster. Okay, to access those, you just go to right click on block diagram cluster and go to this function. So these 4 functions are very useful for cluster type of data. Okay, so I go one by one. Right. So this is first one is the bundle by name. I use this bundle by name function and drag it on my block diagram. Okay, and when I connect this as here on top, okay, so it will just directly pop up the names what are available in the cluster. Okay, so if you want to change some particular value, you just select this one, and I want to add a 10. Okay, so you can change the data of your cluster by using this bundle by name function. Okay, so you connect it to this function, and you add new data for each value, and when you output that data, it will become like this. So to modify the data from this to this, you use this particular function. Okay? Now, if I want to just access one of this data, like I don't want to have all the data out, only one out, means like I just want to know what is the double data here, or Boolean data here, or integer data. So I use this unbundle by name function. Okay, so for that, what you do, just connect the line of your your cluster. Okay, and it will have this information already inside. Okay, so you just select which one you want, click here, and you just get that value out. And then there is a similar function. There are 2 another functions. It is bundle and unbundle. You see each function is the same. These 2 functions and these 2 functions have the same output. Like they bundle the things together to create output, and they underbundle the things. Okay. So what is difference you see is this one name. But when you do just bundle or unbundle, there is no names. Okay. So you have to supply all the data, or you can supply the variable data to that particular sequence. So bundle by name and this bundle or unbundle is the same. Function wise it is same. Only difference is that you will have the independency from the sequence. Okay. So it is the same functionality, like you do modification by bundle and you take out the data by unbundle. Okay. So the cluster is useful for combining the data, and to access those data or modify those data, you use bundle or bundle by name, and to take out the data as indicated for indicator, you unbundle them. Okay. The last type is enums. Okay. So enums is like enumerated. It is short form for enumerated. Okay. So you make a list. Okay. You make a list, and it is related to the sequence. Okay. Okay. So it is kind of integer type of data. Okay. But it is a combination of 2 data, right? One is integer for sure because it is blue color data. But when you see on control panel, front panel, it looks like this or this or this. Okay. I will explain you all 3 different types. Okay. But this is particularly good for giving the user the options. User don't need to enter something. Okay. So when we click on this, you will see the list. So we create this type of data, means user can cycle or ring through available options. Okay. User will see the text, but when on the block diagram, we will get the numbers. So this is combination of data. So there are three types usually. One is called enum. Okay. So enum and text string both looks same. Okay. Both have the text and number. And another one is picture ring, which has a picture, different pictures, and related to the number. Okay. So this is to make user a convenient choice, right? So he has no need to type in anything, but he just select the option and he will give you some inputs for your program. So this is enum type. Okay. So this is when you put this control on your front panel, it will appear like this, and it will be appear as empty first. Okay, and then you right click on that and you click on edit items. Okay, so it will be opened this window. Okay, so here in items you double click here and you type it. Okay, you type some text for your list. This is fixed. Okay, this you cannot change for enum, and these values are assigned to that particular text. But there is a same thing, but here means for text ring, you see the same thing is there. Means you put the text ring on front panel, right? Right click, edit items, and you will get the same dialog where you ask like enter the item. Here you don't have any constraint for like values. You can change text and you assign some number. Enum is fixed list where you don't have anything, anything to define on the number side. But on the text ring side, you have the values which you can define yourself. Okay. So and also it's possible that you can allow the user to define another value than from your list.
It seems more convenient for us to use the text ring. So what are the cases for us to use?
So this kind of list is only used inside the block diagram, okay, usually. And this kind of list is usually used on the front panel of the front panel of your VI. So this is good for user to interpret or enter the data, and this is good for programmer to use inside the block diagram. This is one kind of enum, okay, so, but it has instead of text you use a picture, okay. So it will be empty box, okay, first, and then you start from adding the pictures to that block. So once you add the pictures to the block, it will be saved into your VI, okay. So you just change your numbers and these pictures will change according to that number. So as you know, this control is like picture and number. So picture will appear on your front panel and number will be appear on your block diagram. Okay. So if you want to import pictures, there is only one way to do this is from your clipboard. Okay. So you select your file you want to import to your picture control, copy it, and when it's empty box, right click and import picture from clipboard. Okay. So the picture will appear inside this box. Okay. Now to add extra pictures to this list, you copy the file what you want to add and import picture after or before. So the list will update automatically and copy like this. So this is all about our data types in LabVIEW. Okay. So this is all basic data types, and everything LabVIEW does is uses this kind of data types throughout the VI program. Okay.